So we looked at central tendencies, which were mean, median, and mode. And then we looked at our spreads, our variations, which are range and interquartile range, IQR. Okay, we're going to be using that as well as, how we created bar graphs, histograms, dot plots, box plots, two-way frequency tables. So we're going to be looking at all those types of data displays, and we're going to be then applying our knowledge of central tendency and variation to help us read the data and then interpret the data. So we're going to be like comparing things within the data. Okay? So what we really need to make sure that we remember is that we are going to read the data display to answer questions that are being asked. We need to be sure to look at the labels on the axes, because sometimes they're going to ask a specific question that might have to do with the label that's on the axes. Be sure that you also look at any keys that are provided. So if it is a bar graph and it's a double bar graph or a triple bar graph, you make sure you pay attention to the key that is there so you know which data to look at. Alright, so we have a bar graph here. And our first question, first off, let's look. We're looking at candy sales, okay, by cases. So a case can have like multiple things in it, so it can be split apart. Just keeping that in mind. It says which month had the largest amount of sales. It's fairly easy to see on a bar graph that which month had the largest amount of sales. Here, December, right? Because it's the tallest. All right. So the next question says, how many more cases were sold in February than November? So when you look at February, how many cases were sold in February? 5. How many cases were sold in November? 2. And 5 minus 2 is 3. So 3 more cases. All right. Now it says, what is the total number of cases sold? Okay, so we can just put the total amounts above, or you can just write them out. So our first one is 5.5, so I have 5.5 plus 3 plus 2 plus 6 plus 4 plus 5 and plus 2. And what was our total amount of cases that were sold? 27.5. And then it says, between which months was the largest increase in sale? So we're looking for increase in sale. So between September and October, we had a decrease. Between October and November, again, had a decrease. November and December, we had an increase. In January and February, we had an increase. But which one's larger, between November and December or January and February? November and December, because we would have 6 minus 2, which would be 4. So our November to December would be the largest increase of 4 units, 4 cases. Alright, so that's with a bar graph. So this is a histogram, okay, and we're looking at masses of fish and their frequency of how often we catch them. I'm going to, it's kind of hard to see, I'm going to give you guys these numbers. This is 3, this is 7, 13, and 6. I understand that they shouldn't have both numbers here. It should be 10, then 12, then 14, then 16. They could have the 18 though there. Not everyone that makes histograms makes them properly, but this one was one that was found, so I didn't want to create a new one. All right, so which interval includes the weight of the most fish that were caught? Okay, so what is my interval for the most? 14 to 16. Okay, how many more fish weigh 12 to 14 kilograms were caught than 10 to 12 kilograms. So I'm looking from 12 to 14 to 10 to 12. So I'm gonna take 7 and subtract 3, and I'm gonna get 4 kilograms. Okay, how many total fish were caught? So we're gonna add up all of our numbers, which they have up there, but we have 3 plus 7 plus 13 plus 6, and we will get 29. Okay, so that part is pretty easy. Those are simple questions of just looking at like what is the most, what is the difference, how many are total. Now we're going to be looking at more detailed questions like that go along with our central tendencies and our variations. So mean, median, mode, standard deviation, IQR, and range. Okay. Alright, so it's asking us to find the mean of the data. Alright, so there's a few ways that you can do this. What I like to do anytime that I have a dot plot or something like that, or a bar graph, they don't just list out the numbers for you. I like to, it's easier to find my mean if I take in each category, I multiply by the number in that category. Because I would have to had 0, 1, 2, 3, 4, 5, 6 times, but I can just take 6 and multiply it by 0 and get a total here of 0. And then 2 times 1 is 2, and then 2 times 3 is 6. 3 times 1, 2, 3, 4, 5 is, and 2 times 4, 8. 5 times 5 is 25. 2 times 8, 16. 3 times 9, 27. 1, 2, 3, 4, 5, 6, 7 times 10, 70. 11 times 4, and we only have 112, so 1 times 12 is 12. Okay, then we can just add up those numbers. So it's not as much work as adding up each individual number to find mean. So I got 225, and there's a total of 40 numbers. So what would my mean be? I got 5.6. $225 divided by 40. 5.6. All right. This question could also ask you to find the standard deviation. So how we find the standard deviation is we take each individual number, we subtract the mean, then we square it, then we add up all of those numbers, and then we divide it by how many numbers there are, then we square root it, okay? I gave you the standard deviation of 4.02 just because of time, but sometimes you'll have to find it as well, but we've already done standard deviation. All right, so this is how many people are within one standard deviation of the mean. All right, so what does that mean? That means our mean is in, let's say our mean was in the middle. It's not the middle term, but we're looking for one standard deviation above, so we would add the standard deviation. And then we could also do one below, because it still would be within 1. So then I would also subtract the standard deviation from the mean. Okay? So I'm going to take my mean, which is 5.6, and I'm going to subtract one standard deviation, because that'll be one behind it. So I'm going to subtract 4.02. And we get 1.58. Okay? Then I'm also going to take my standard, my mean, and add my standard deviation, because that would be one more than one standard deviation towards the positive. So I'm going to take 5.6 and add 4.02. I got 9.62. All right, so we're looking for all numbers that are within this amount, okay, that range from 1.58 to 9.62. Okay, so is 1 larger than 1.58? No. Is 2? Yes. So 2, that's going to be my starting point, okay? How about 9? Is 9 less than 9.62? How about 10? No. So it's all numbers that are less than 10. Okay, so let's count how many dots are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there are 20. 20 people within 1 standard deviation. Because it's the standard deviation away from the mean. 1 away towards the positive and 1 towards the negative. Because it's still 1 away in either direction. Okay? Yes. 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 I counted my number of dots. These are the number of people. And these are my range of standard deviation. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. So that is a standard deviation type of question that they might ask. Then this one says find the mean and the IQR. So in order to, or the median, I'm sorry, the median and the IQR. So in order to find our median, we have to list each number out, okay, from least to greatest. And then we have to find the middle. I don't want to have to write it so much times. All right. So I list each number out. I found my middle, which is 5, my median. My median is 5. The upper quartile is 10. My lower quartile is 2. That's what we did 2 days ago. And then our IQR is 10 minus 2, which would be 8. So our median is 5, and our IQR is 8. So then it's asking us for how many people are in between, are in the interquartile range. Yes. You could do that. Yes. You could go in and cross out the dots, like so. You could have gone in and, let me erase that. Go like this. Dot, 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 dot.
And so on.
And so on, okay? Until you get 5 and then 10 and 2. But then you know what I mean? Okay. So then, we have to find out how many people are within the IQR. So there's multiple ways we can do this. We can do the same thing like we did with here, where I'm in between 2 and 10, but we don't include, the range between 2 and 10. Or, if you think about this, the IQR is the interquartile range. That's this range right here. This is broken into 4 quartiles, right? Right? 4 quartiles? Yes. Each quartile has the same amount, it's 25%. So what is 25% of our total, which was 40? Well, what is 40 divided by 4? 10, right? So there would be 10 people in our lowest quartile, 10 people in our middle quartile, 10 people in our middle upper quartile, and 10 people in the last quartile here. Did you see that? So in our interquartile range, how many people would there be? 20. So that's one way of thinking it. And then, okay, we're going to talk more about what measure of center and spread is more representative of the data next week. But we need to talk about, I'll go more into this later, but we're going to talk about the median and the IQR are more representative because let's think about our mean. Our mean was 5.6. So that is here. Are there any points at 5.6? If 5.6 would be rounded, would be 6, right? Up to a whole number. Are there any data points at 6? No. 5 was our median. Are there data points at 5? Yeah. This is more representative. And any time that you have the median, the type of spread that you're going to have is your IQR. They go together. Anytime that you have a mean, the spread that you're going to have is either going to be the standard deviation or the range. And IQR of 8 represents more data than our standard deviation, which is only 4, and our range, which would be really big. Okay? 12. Okay, so median and IQR are the best fit for this data.